This last section in Unit 3, Section 3.10, is all about isotopes. We're going to define them in a little more detail. I know we have mentioned them briefly in a few past lessons, but let's define them in our notes here. So, isotopes. Basically, atoms of the same element can sometimes have different numbers of neutrons. Remember, they will never have different numbers of protons. If there's a different number of protons, it's a totally different element. But atoms of the same element can have different number of neutrons. It's just the way it is. Like some people have blonde hair, some people have brown hair. There are a different number of neutrons. Okay? So when you have this, you got atoms. Remember we said same number of protons always, but different number of neutrons. Those are called isotopes. Okay? And so what happens when we have different number of neutrons? It basically affects the mass number of the element, but not the atomic number. Remember that atomic number is the number of protons. It will never change. But the neutrons, they do have some mass, they have some weight, so they will affect the mass number. And we just want to briefly say that some elements have many isotopes found in nature. There are some that have 10 or 12 isotopes. Gold is one of them that just has a bunch of different isotopes with different number of neutrons. So that's basically what an isotope is. You will be definitely doing a lab to practice with some of that information here for this section. While we are here, though, we also want to define what an ion is. It will become very important later on. So we're going to define that right now as we're talking about electrons. And an ion basically is when an atom loses electrons, it becomes positively charged. Positive, E-L-Y. Electron is negative, right? So when there are less electrons, then the charge of the whole atom is positive. Positively charged atoms are called cations. The opposite is true. Also, we need to define when an atom gains electrons. So it has more electrons, more negative, then it's negatively charged. And those negatively charged atoms are called anions. And the way we designate that, whether it's positive or negatively charged, is there we do a superscript. That's the little number up high, not like a subscript down low, but up high, right? It shows the charge on an ion. So if you look here, my picture, here's oxygen, 8 protons, 8 neutrons. And as we can count here, 1, 2, 3, 4, 5, 6, 7, 8 electrons. So the same number of electrons as protons means it's neutrally charged. There is no charge, not positive, not negative. But we can look here at this atom, still oxygen, 8 protons, 8 neutrons. But if we count the electrons, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 electrons. So remember, when we have more electrons, it's negatively charged. Because here we have like a negative 10 and a positive 8, which makes a difference of negative 2. So that, let me make my positive a little bigger. That negative 2 superscript says that this oxygen has 2 extra electrons. That's how you abbreviate electron. Minus, because it's negatively charged. So there are 2 extra electrons here, which gives it that negative 2 charge. Okay. So at the bottom of this note sheet, there's some practice problems. See if you can work them out. I'll do another video that gives the answers for all of these. But first, sit down and see if you can't work them out on your own.